Hi students, in this session we are going to discuss few more problems based on series and parallel combination. Okay, and after these problems we are going to discuss how the total amount of electric energy is calculated. Okay, by using a power based formulae. Okay, now in this we are going to do the problems based on series and parallel combination in this particular session. Now the first problem is as follows: calculate the resultant resistance and current in the given circuit. He asked to calculate the resultant resistance and as well as the current present in the given circuit. Now circuit is given like this. Now we have 2-volt battery and we have 3 resistors, and these 3 resistors are connected according to the diagram. Now we have to calculate the equivalent resistance. First of all, we need to check how they are connected. Now these two, in this given circuit, these two resistors are connected in series combination. See, now these two are in series combination. First we have to calculate the series combination resistors equivalent resistance, and after that we need to modify the given circuit according to the value what you are going to get now here. So the first one is these two are 3 resistors are there. Now in these 2 resistors are connected in series combination. First of all, we will calculate the equivalent resistance in case of these 2 resistors. Now we are having the series, these two are in series combination. I will name it as this is R1 and this is R2. Okay. Now, and in series combination equivalent resistance formula is R equivalent resistance or resultant resistance is equal to R1 plus R2. Okay. Now I told you these two are in series combination. Okay. So the equivalent resistance R equivalent is equal to R1 is how many ohm? 30 ohm. That is 30 ohm plus R2 is how many ohm? 30 ohm. Now we got R equivalent resistance is equal to 30 plus 30. You know that there is a 60 ohm. Now we calculated the equivalent resistance or resultant resistance of these 2 resistors only, not the entire circuit. Now after calculating this, then we have to check after calculation of this series equivalent resistance, then the circuit should be a bit of modification will be there here now. Now I will draw the circuit. I hope you all understood up to here. Just I will erase this combination, and now we calculated equivalent resistance of those 2 resistors, and which you got is a 60 ohm. Now I will modify the circuit. Resultant resistance you got how much is this is 60 ohm. I will consider. Now I will now here one resistor, this is 30 ohm already given, and equivalent resistance we calculated. Now I will make it as 60 ohm now. Okay, now this is, now the circuit is modified like this. Now here it is R1 you consider R1 is equal to 30 ohm now, and this one you consider as R2 is 60 ohm. Now how these two are in parallel combination. Then you have to calculate 1 by R is equal to parallel combination formula to find out the equivalent resistance. 1 by R is equal to 1 by R1 plus 1 by R2. I will make it as equivalent resistance or resultant resistance. 1 by R equivalent. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Now these two are in parallel combination. Now I will substitute the values. 1 by R equivalent or resultant resistance is equal to 1 by R1 is how much? 30 ohm. That is 30 ohm plus R2 is how many ohm? 60 ohm. So this is 60 ohm. Okay, this is a 60 ohm. Now 1 by R equivalent is equal to LCM is 30 and 60. LCM is how much? 60. Now 30 will go in 60 2 times. That is 2 plus 60 will go in 60 1 time. So 1 by R equivalent is equal to 2 plus 1 by 60. Then if I write this, I will continue this problem here. 1 by R equivalent or resultant resistance is equal to 3 by 60. Now I will do reciprocal. R equivalent is equal to 60 by 3. Okay. Now 3 1 ja, 3 2 ja. That is R equivalent or resultant resistance is equal to how many ohm you got? 20 ohm. Now we got equivalent resistance of the 3 resistors which are connected according to the given diagram. We already done that. Okay, then equivalent resistance you got is how much? R equivalent is equal to 20 ohm. We got resistance value. Then we got total resistance in the given circuit or resultant resistance or equivalent resistance. Okay, we calculated the value, and value we got as okay, R equivalent is equal to how many ohm you got? 20 ohm. Already we done the problem. Now he asked to find out the current in the circuit. Now according to the given circuit diagram, and we are having voltages or potential difference, how many volt? 2 volt is there. Now you have to calculate current is how much. Then here you have to apply Ohm's law. According to Ohm's law, we know that V is equal to IR and I is equal to V by R. Now substitute the values of okay, V and R in this. V is how much? That is 2 volt, and R is how much? How much you got? 20 ohm. Na? That is, I will erase this one V. Now how much? This is 2 1 ja, 2 10 ja. I is equal to how much? 1 by 10, nothing but 0.1 ampere. I told you in the previous classes, in previous videos, okay, 0.1 ampere. If you want to write in short form representation, you should write capital letter. If it is in complete unit, means 0.1 ampere, you have to write like this. Okay, I hope you all understood this problem. Okay, please copy this. Now we will discuss another problem. The second problem is, the data is given as follows. The problem is, show how would you join three resistors, each of resistance 9 ohm, so that the equivalent resistance of the combination, first one is 13.5 is giving for one combination. For another combination, he got 6 ohm. Then how you got these values? Let us see. First, we will try to go with the one combination. Okay, the problem is, show how would you join three resistors, each of resistance. I will take R1, one resistor is R1 is 9 ohm, and second resistor also R2 is equal to 9 ohm I will take, and third one also R3 is equal to 9 ohm I will take. Okay, we got three resistors, each is having the same amount of resistance, that is 9 ohm, 9 ohm, 9 ohm. Okay, we asked to calculate how do you connect the resistors to get, in order to get 13.5 ohm resistance and 6 ohm resistance. First, if you connect all these three in a series combination, you never get these values. If for your understanding purpose, if I connect three resistors in series combination altogether like this, okay, 9 ohm and 9 ohm as well as 9 ohm. If I connect all these three in series combination, I am not just, I am simply drawing this uh, complete circuit like this, and this is a battery, you know, okay, and this is a switch. Now I am not giving any values here for battery, nothing. Okay, just we are going to calculate the equivalent resistance for this combination. If I calculate equivalent resistance, it will become R equivalent is equal to R1 plus R2 plus R3. Then R equivalent is equal to R1 is how much? 9 ohm, 9 ohm and 9 ohm. Then how much you are going to get? R equivalent is equal to 9 plus 9, 18. 18 plus 9, how much? 27. So it is not possible. Series combination connection is not possible because the values here you got is 13.51 and another one is 6 ohm. But how much you got if you connect in series combination? 27. So hence this combination is not a right combination. Then we have to go with the other alternative circuit combinations. That is, next I am going to connect two resistors in parallel. Another one is in series. Like this, if I connect. Now here R1 is equal to 9 ohm, R2 is equal to 9 ohm, and this one has R3 is equal to 9 ohm. If I connect like this, you will check how much value you are going to get. Okay, whether you are getting any one of these values or not. Now, first of all, I am going to do what combination here? These two are in parallel combination. So, when the circuit is in parallel combination, now value to calculate the equivalent resistance formula is that is 1 by R is equal to 1 by R1 plus 1 by R2. First, I will do these two in parallel combination. So, 1 by R is equal to 1 by R1 is how much? 9 ohm. And 1 by R2 is also 9 ohm. Now, 1 by R is equal to LCM is 9 as usual, you know. Okay, that is 1 plus 1. How much? 2 by 9. Nothing but 1 by R is equal to, that is 2 by 9. And reciprocal, if you take R is equal to 9 by 2. 2 1 ja, 2 4.5 ja. That is 4.5 ohm you got. Well, we got 4.5. Then these two equivalent resistance you got 4.5. Now I am going to compress the circuit. These two result resistance you got, I will make a single resistance. Okay, this is 4.5 ohm. Okay, and another resistor is there, how much? We are having a 9 ohm is there already. Okay, then now what to do? These two are in which combination now? These two are in series combination. Then you have to calculate R equivalent resistance is equal to, this one you consider as R1 is equal to 4.5 and this is R2 is equal to 9 ohm. R1 plus R2, R equivalent is equal to R1 plus R2, nothing but R1 is 4.5 plus R2 is 9 ohm. So R equivalent is equal to 4.5 plus 9, 13.5 ohm. I hope you got this value. The first equivalent resistance value, how much you got? 13.5 was given. So this is the right combination. So the three resistors were given. Now two you have to connect in parallel combination. To those two resistors, we are going to connect one more resistor in series combination. Then the resultant, after calculating the total resistance, the value we got is 13.5 ohm. So the first, to get the first value, the combination should be like this. I hope you all understood. Okay, next combination we need to check. Now we have to get the next value is a 6 ohm. We have to get then what type of a combination we have to do, that how the connections are made. Now I hope you all understood the first value, how you got that 13.5 ohm, and the second one we have 6 ohm. Then how to get this value, sir? Then I will go with the another combination here. Now we are going to connect two resistors in series and the third one is in parallel to the first two. Now here you consider this one as R1 is equal to 9 ohm. Here R2 is equal to 9 ohm, and this is you consider as R3 is equal to 9 ohm. Okay, so this is the combination. If you want, you can connect one switch, and I am not giving any values to the respective battery or a source of voltage. Just simply I am mentioning as this is a B and this is a switch. Now we have to connect, we connected these two in series combination. We have to calculate equivalent resistance here. So for equivalent resistance, R equivalent is equal to R1 plus R2. I hope you all are getting my explanation. Now R equivalent is equal to R1 is how much? 9 ohm. Okay, plus R2 is also 9 ohm. So R equivalent is 9 plus 9 how much? 18 ohm. You got this value in these two combinations. Now after that, what to do, sir? Then these two equivalent resistance you got how much? 18 ohm. Now I will make it a single resistor, that is 18 ohm, and one more already there which is of 9 ohm. Okay, now this is a plus minus and this is switch and this is a battery. Now we have to calculate equivalent distance of these two resistors. Now these two are together in which combination? Means parallel combination. Then I will solve even that one also, whether we are getting the 6 ohm value or not, we need to check. Okay, now for this case, so these two are in parallel now. 1 by R is equal to 1 by1 by R1 plus 1 by R2. 1 by R, if you want you can write equivalent resistance is equal to 1 by R1. R1 is this one you consider as R1 and this one you consider as a R2 ohm. So that is R2 is equal to 9 ohm. So 1 by R1 is how much? 18 plus 1 by R2 is nothing but 1 by 9 ohm. That is 1 by R equivalent is equal to, LCM is how much? 18. 18 will go in 18 one time. You know that one. This is 2 times. It will become 3 by 18. Reciprocal if you do. R equivalent is equal to 18 by 3. 3 1 ja, 3 6 ja. So R equivalent is equal to how many ohm you got? 6 ohm. I hope we solved both the resistances, okay, connected in different combinations. How to connect the resistors to get so and so of resistance, I think 13.5 ohm, and how to connect the resistors to get the resistance of 6 ohm. I hope you all understood this problem. Please copy this. Now another problem based on calculation of total amount of electrical energy or cost of electrical energy used in a month of, used in 30 days, or for a month of 30 days, for a month of 31 days, for a month of 28 days, or for a month of 29 days. Now this problem sometimes chance of getting in the board examination either in 4 marks, if luck favors it is 6 marks. Reason is very easy problem. Problem looks, it's a very big problem like that, but it is very much easy problem. You can understand this problem very, very easily. Please concentrate. I hope so. Very few of you know this, how to do. Okay, now see the problem. A house has 3 tube lights, 2 fans and a television. Each tube light draws 40 watt, the fan draws 80 watt and the television draws 60 watt. On the average, all the tube lights are kept on for 5 hours, 2 fans for 12 hours and the television for 5 hours every day. Find the cost of electric energy used in 30 days at the rate of rupees 3 per kilowatt hour. So finally what you have to do, we have to calculate total electrical energy consumed for a month of 30 days when you use all these appliances. Okay, and we are going to write the steps. Please concentrate, don't miss this problem. Sometimes I told you now, if luck favors, this problem comes under 6 marks. Okay, so I hope you won't skip the video in between. Please continuously watch the video, don't skip the video, please. Okay, house has 3 tube lights. Now I will write all the steps. Number of tube lights is equal to how many? That is 3 tube lights. Now for your clear understanding, number of tube lights. So I will make it as NT, number of tube lights. How many? 3. Next, 2 fans, number of fans. That is NF. For your understanding purpose, I am giving this symbolic notation here. A number of fans. How many? 2 fans. Next, and a television, number of televisions, TV, simply I am writing NTV is equal to how many? 1. Okay, the fan draws 80 watts. Power of each fan is equal to how many watt given? 80 watt. Okay, 80 watt. Next, power of each tube, 40 watt was given. Next, and the television draws 60 watt. Power of television, each appliance draws how much amount of power? That's why I'm writing the steps. Power of TV here. Okay, how much power they are going to draw? Okay, is how many? 60 watt. It draws 60 watt. So fan draws 80 watt, tube draws 40 watt, and TV draws 60 watt. Now, before we complete the problem, we should calculate what is this, how to calculate the total power. First of all, I will calculate the total power. Now, time off, even I will write the other step. On the average, all the tube lights are kept on for 5 hours. Okay, so time off, I will write the step time of, okay, use, okay, of tubes is equal to how many hours we are going to on the tubes on for 5 hours, that is 5 hours. Next, time of use of what? The next one is fan. How many hours is given? That is 12 hours. It's a very big problem. Please don't skip the video. Next one is time of use of TV. How much time you are watching? Now 5 hours. I hope you all are wasting so much time even during exams if you watch like this. Okay, so TV 5 hours. I hope you all understood all the steps. Now what to do, sir? First of all, we should calculate total power the tube light draws. Okay, if it is total number of tube lights are how many? 3. Okay, power of each tube is how many watt? 40 watt. And how many hours the tube light is kept on? 5 hours. First of all, you have to do that. Just I want to erase this upper part of this problem. I hope you all already written this problem in your book. Uh, Now I will write the steps related to, that is total power, okay, drawn by tubes is equal to, formula is number of tubes into, okay, power of each tube, power of each tube, power of each tube into time. How much time they are on? They kept on. Now that is total power of, total power of tubes is equal to, number of tubes how many? I told you that is 3 into power of each tube is how much? That is 40 into, that is kept on for 5 hours. How much? 3 into 40 into 5. It will become 5 4 that, and this is a 600 watt. Okay. 5 4 ja 20, 200, 200 into 3, that is 600. So we got total power of a tube. Okay, tubes. Next one, we have to calculate total power of, water fan, total power of fans. Okay, I will write total power of fans. Simply, total power of fans, total power of tubes, total power of fans is equal to, now we are having is number of fan. How many number of fans? 2. That is number of fans into power of each fan into time. How much time you are going to switch on the fan? That is how many hours you are using that per day. That is next. I will write number of fans how many? That is 2 into power of each fan is how much? 80 into time. How much time you are going to switch on the fan? 12 hours. That is equal to, how much you are going to get? This is 160 into 12. How much you are going to get? There is a 0, 12, 2 1 ja, and 3. And after that you are going to get 0, 6, 1. That is 1920. The value of total power is 1920 is the power of, total power of that is a fan. Next one. Now I will erase this part because I will erase this one. Now I will write the next part because you should keep this one. We have to calculate the bill. Now fans is over. We calculated the value even. No, 1920. That is 1920 watt we calculated. That is total power of fans. Next one is television. Now, total power of TV is equal to number of TV into power of each TV, that is total power drawn by the TV, okay, into how much time you are going to watch TV, that is 5 hours, that is time. I will write simply time. Now I will erase this because we got almost all the values we got. Next, even I can rub this. Okay, now total power of TV, total power of TV is equal to number of TV, how many? 1 into power of each TV, that is I hope it is given as a 60 into time is 5 hours. Okay, now total power of TV is equal to, this is 300 watt, and this is a watt, this is also watt, this is also watt. Now we have to calculate total power of all appliances is equal to, now we have to add all these. Total power of tubes, how much you got? 600 less total power in terms of fans 1920 plus how much? Next one is TV 300. If you calculate all these, how much it will become? 900 plus 1920, it will become a 2820 watt. Okay, so we got total power of all the appliances. Now we have to calculate total electrical energy consumed, okay, in kilowatt hours. First of all, we have to calculate total electrical energy, and even in kilowatt hours for a month of 30 days. Now I will write total electric energy. The step is total electric energy consumed for a month of 30 days. Nothing but that is in what? Kilowatt hour. Okay, is equal to total power of all appliances into number of days by 1000. We have to do number of days by 1000. Next, after that, now we got total power, we already calculated, and please remember this value. I am not dropping this. Okay, how much? I will write this one at the top. Government is charging 3 rupees per kilowatt hour. Okay, that you have to remember that value. Next, total power of all appliances, how much you got? 2820 into, okay, number of days for a month of 30 days given in the problem. Next is 1000. Now 0, 0 cancel, 0, 0. It will become 282 into 3 by 10. Okay. And now it will become 282. Do multiplication also. 6, 24, 6, 8. That is 846 by 10. I can write as 84.6. I hope I can write like this. 84.6 I can write. Okay. That is kilowatt hour. So this much electrical energy we consumed for a month of 30 days. Then the government is charging rupees 3 per kilowatt hour, or per 1 unit government is charging 3 rupees. Now cost of 1 kilowatt hour or 1 unit is equal to how many rupees? I told 3 rupees. Now total bill is equal to number of units into, okay, cost of 1 unit. Nothing but total number of units you got 84.6 units into cost of 1 unit. Government is charging 3 rupees. Now you multiply these two, you will get 84.6 na 3. Okay, 3 6 ja 18, 3 4 ja 12 plus 1 13, 3 8 ja 24 plus 1 25. That is 253 rupees 80 pies. Okay, 253.8 rupees. Is it clear? Okay, I hope you all understood this problem. It's a very important problem. If you all are happy with my explanation in today's class or in this video, okay, please comment, share and subscribe. Thank you.